Lesson 67 has a title of Using Prime Factorization to Reduce Fractions. So what we want to do in this problem is we want to reduce 375 over 1000. We know we can reduce this because both numbers must be divisible by 5. We could divide both numbers by 5 to get us started with reducing. That's one way to do it. Another way to do it is to use prime factorization. Now, to use prime factorization, remember we have to use factor trees. So 375. We're going to break that apart into some numbers. Let's break it into 5 times something else. We have to figure out what 375 divided by 5 would be equal to. 5 times what is 37, or closest to 37? That must be 7, because 5 times 7 is 35. We subtract and we have 2 left over. We bring down our 5. 5 goes into 25, 5 times. We have nothing left. So, we get 5 times 75. Now 75 is like 3/4. So, if we had 3/4, that would be 3 times 25. And 25 is the same thing as 5 times 5. So our prime factorization is going to be 5 times 3 times 5 times 5. That's the first part of our problem. I'm going to erase this work on the side so we have room for the rest of our work. Let's look at 1000. We want to reduce 1000 by using prime factorization. So 1000, well 1000, that's the same thing as 10 times 100. We know 10 is 5 times 2, two prime numbers. 100, well 100 could be 10 times 10, and 10 is 5 times 2, and 10 is 5 times 2. Now this takes a moment to go ahead and go through the prime factorization of these problems, but you'll see why we do it. The reason that we do this is because we can now set this up as a fraction. So 375 is 3 times 5 times 5 times 5. 3 times 5 times 5 times 5. And 1000? 1000 is 2 times 2 times 2 times 5 times 5 times 5. Now when we've got it set up like this, we can reduce the fractions that are equal to 1. We want to find out where we have a fraction equal to 1. Well, we have 5 divided by 5. That's a 1. We can always work diagonally. 5 and 5, that's a 1. 5 and 5, that's a 1. So we're left with 3 as our numerator, and 2 times 2 times 2 as our denominator. So we've got our final answer. Numerator is 3, denominator is 2 times 2 times 2, that's 8, so we get an answer of 3/8. We're all done. We've fully reduced this fraction, and we've done it using prime factorization and reducing those fractions that are equal to 1 before we multiply. Let's look at one more example. Here we want to reduce. We've got 125 over 500. So 125. Well, if we broke that into parts of 25, we'd have to have 5 25s. It's like having 5 quarters to get us $1.25. And then 25, well that's 5 times 5. So we have 5 times 5 times 5 as our prime factorization. We can write that out. For 500, well for 500, we have, well we could do 10 times, well what would we have to multiply 10 by in order to get to 500? We'd have to multiply it by 50. 10 we know is 2 times 5. 50, that could be 25 times 2. And 25 is 5 times 5. Now remember, it doesn't matter what numbers you break your branches into. This could have been 250 and 2. Right? It could have been lots of different possibilities, but the important thing is that you get down to the prime numbers, and you'll get down to the same prime numbers as long as you get each step correct as you go. So we've got it. What we have is 2 times 2 times 5 times 5 times 5. 2 times 2 times 5 times 5 times 5. We can now reduce those fractions equal to 1. We've got a 5 over 5, very good. A 5 over 5, that's 1. And a 5 over 5, that's 1. So our answer, well, we've got 1 times 1 times 1 in our numerator. That must be 1. Our denominator, well, we have 2 times 2 left over. That's 4. So we've got 4. We've got our answer, 1/4. When we use this prime factorization, it helps us to find the prime numbers that we can then write to help us reduce our fraction by simplifying fractions equal to 1 before we multiply. We've got our product here. 125 over 500 is the same thing as 1/4. Lesson practice will be on page 357. Make sure you've got your notes complete, and I'll see you during our next class.